Well, here we have our first problem of the activity 5, and the problem is the number 2. We have to solve with the given conditions. Here we have the problem is the double derivative of y plus 4 plus y derivative plus 4 multiplied by y equal to 0. We have that the initial conditions are in y we have 1 when it's 0, and when it's derivative we have that the initial value is 2, like you can see here. Then we proceed to change the problem with the lambda. We have lambda to square plus 4 multiplied by lambda plus 4 equal to 0. Here we can see that it's a second case problem. What is a second case problem? Because we have equal roots, as you can see here, with the 4 and the another 4. We have the two roots of number 2. Then we substitute in the formula and we obtain y is equal to constant 1 multiplied by e elevated to minus 2 x plus the constant number 2 multiplied by the x. Remember, do not forget to put the x because we have the same root in order to differentiate the terms. And we have the constant number 2 multiplied by x multiplied by e elevated to minus 2x. Then we substitute with initial conditions with 1 in order to obtain the value of the constant number 1. Here we have, when we change the value of x for 0, we cancel all of this. This is number 1, so this multiplies and it's still the constant number 1. So we have finally that the constant number 1 is equals to 1. Now the second step is to derive the substitute that we did before, and we obtain this. Here is the minus 2 multiplied by constant 1 for e elevated to minus 2x plus constant 2 all multiplied by minus 2 for x, that in this case is 0 because it's initial condition, we multiplied by e elevated to minus 2x plus e elevated by minus 2x. If we substitute the initial conditions in this formula, we obtain this, and if we separate the constant number 2, we obtain that the constant number 2 has a value of 4. And then if we obtain the particular solution with the value of the constants, and we obtain that y is equal to e elevated to minus 2x plus 4 multiplied by x multiplied by e elevated to minus 2x. Well, here we have our second problem. We have that the triple derivative of y plus 5 to y double prime plus 12 derivative of y plus 8 multiplied by y equals to 0. Then we change our formula with lambda, and we have lambda elevated to the square plus 5 multiplied by lambda elevated to here we have lambda elevated to the cubic, to the third, plus 5 elevated to the square plus 12 multiplied by lambda plus 8 equals to 0. Here we have the case of the higher terms, so we have to use the synthetic division in order to find the roots for our solution. Here we have, remember to always use the last number of the equation. We have the number 8, and here we have all the possible solutions of the synthetic solution, of the synthetic division. We choose the number -1, and as you can see here, we did the synthetic division and we obtained the 0 that indicates that is correct. So lambda is -1. Then we have the another formula that is lambda to the square plus 4 lambda plus 8. In order to find the roots of this, we have to use the general solution. We substitute here in the general solution. We did all the steps in order to find the roots and the imaginary number, and we obtain that we have -2 plus -2 imaginary. Then if we substitute this in order to find the particular solution, we obtain that y is equal to constant 1 multiplied by e elevated to -x plus e elevated to -2x, all multiplied by a sin of 2x plus b cosine of 2x, and then we have our solution. Well, here we have another problem of the activity of the reduction method. The problem is we have the equation y multiplied by y double derivative equals to y derivative elevated to the square. We know that y derivative is equals to c, and the double y derivative is equals to dc over differential of y. Then if we substitute this in the formula, we obtain this y multiplied by c multiplied by differential of c divided by differential of y equals to c elevated to the square. Then what we proceed to do, we move the dy to here in order to separate the y's and the c's. As you can see here, we have in one side we have the c, and in our side we have the y. We proceed to integrate that. Here we eliminate this, and we have a direct integration of logarithm, and we obtain natural logarithm of c equal to natural logarithm of y plus natural logarithm of a constant 1. Then we apply the rule of the e, and we eliminate the logarithm, and we obtain this. The rule of logarithm tells us that if we are adding two logarithms, we can multiply them, as you can see here. That's why we obtain c equals to c to constant 1 multiplied by y. Here we have to substitute the c for the differential of y divided by differential of x equals to constant 1 multiplied by y. Then we proceed to integrate the two terms of this, and we obtain the constant number 2 multiplied by logarithm of y equal to x plus constant 3. Here what we did is that we passed the constant number 2 to the other side dividing in order to change this, or to rename this for another constant. Then here we eliminated the logarithm, the natural logarithm, and we obtain constant number 4, that is the one that we renamed, plus e elevated to constant number 5 plus x. Well, here we have our last problem of the reduction method. We have minus double derivative of y equals to y prime elevated to the square plus 4x. We substitute with the values of c, and we obtain this, that is minus c prime equals to c elevated to the square multiplied by 4x. Then we proceed to substitute the value of c, and we obtain this, the two differentials. Then we separate the differentials of the same letter to the same side we have the x in one side and the c in one side. We proceed to integrate that and we obtain this. Then we substitute again the value of c and we obtain the differential of x over the differential of y equals to the previous integration of the x term that is 2x to the square plus constant 1. Then we proceed again to separate this with the both sides of the same letters. Here we have the x in one side and the differential of y in the other side. We proceed to integrate that as in the previous step, and we obtain that y, here is the y, is equals, we know that here we have to use the arcotangent in order to find the solution. So we have 1 over the constant 1 plus tangent minus 1 multiplied by the root of 2 multiplied by x divided with the constant number 1, all of this, and then plus constant number 2, and then here we have our final solution.